So I hope you guys can see my screen now.
Yes, you can.
Good morning, everyone, if you're PST, and good afternoon otherwise. Welcome to Akri's developer meeting for the month of March. Time flies quickly. So today we have a couple of announcements. We'll start with talking a little bit about the CNCF live webinar. Kik is going to give us an overview about that, Akri release, and then a bunch of other things on the agenda today. So welcome, Jonathan. And with that, we can get started. Kate, do you want to give an overview about what's going on today?
Sure. Yeah, I guess it's a little exciting today. We're doing our first CNCF live webinar. So since Akri became a CNCF sandbox project, this is one of the benefits. We get to kind of join the CNCF community a little more actively. So we're doing a webinar literally right after this. I'm going to hop off in probably 30 minutes. And this one's going to feature a lot of our latest and greatest. So previously with Akri, we really focused on discovering and using devices. And in our latest release, we added support for deploying Kubernetes jobs to devices. So this kind of opens up more scenarios, specifically management and scenarios. So this live webinar in it, I'll demo a firmware upgrade of an IP camera to kind of show how one of those scenarios could look. So that's right after this. They're all recorded too, so feel free to watch it on replay. And kind of, yeah, any questions on this, I guess?
Cool, can anybody join? I think with this link would be where everyone can join, Kate.
Yeah, so you just, I think the login to RSVP does it, and then from there you can watch it.
Awesome.
And then on the second note there is our release. So that pairs well with the previous announcement. Our version 0.8.4 is out. Yeah, that would be great to go to the release notes there. Thanks, Ra. So what this features is 3 main buckets, I believe. The first one is what I mentioned, jobs. This was a breaking change. So our configuration CRD, which is where you tell Akri what to find and what to deploy, we changed it so that now what you can deploy is two-part. You can either deploy Kubernetes jobs or Kubernetes pods. So that's why it's a breaking change. We also added a fix that allows you to deploy multiple configurations that use the same discovery handler. This was a feature that we lost when we built out our extensibility model, but it's back. And then finally, we used to have a pre-configuration step where you had to install CRI-CTL to kind of query what pods are running on each node. And now we embed that in the agent container so that you don't have to do that installation yourself. The reason we use CRI-CTL is because the device plugin interface does not support a deallocate, which means that we don't know if a pod is no longer using the discovered devices. And so we do this to kind of ensure that every pod that we think is running is still running. There is work, and Ro has been tracking this in SIG-Node to maybe add that support. So hopefully we can eventually remove CRI-CTL, which does add weight to the container, but a little background on that. So if we go, I think that's all of our announcements. And I think that also gets us through the first item of the walkthrough of the release notes.
Sure, do you want to share, or do you want me to go back to the...
Yeah, I guess maybe go back to the release notes. There might be some other things. Yeah, the only thing I would say is if you previously have Akri installed, delete the configuration CRD so that you pull down the latest one. And we also did some optimizations, like reducing the size of our brokers. And yeah, I would say that's about all for our release.
We also added like testing for the new Kubernetes, right?
Yeah, so that's a good point. So you'll notice if you scroll down a little, Roa, that for MicroK8s and K3S, we're up to the latest. So MicroK8s' latest is 1.23, K3S's is 1.22, but you'll notice that for standard Kubernetes, we aren't. And that's because now Kubernetes uses containerd, and so we need to update our end-to-end test installation for Kubernetes. And so we did not bump that, but there's an issue on Akri. If anyone's interested in contributing it, you don't need any background on Akri to do that. It'd be a great way to help out.
Is that to say that there's a known problem with the newer versions of standard Kubernetes, or just our tests haven't validated it on newer platforms? We expect it to work, we just haven't validated it, or what's the story there?
Exactly. And I think we have someone, I think, has run it on latest Kubernetes. It's more just that in the GitHub runners where we do our tests, we aren't properly installing Kubernetes with containerd. And so for that reason, if you try to install Kubernetes, for that reason, we just need to do a little bit more work there. So in our release process, that work wasn't prioritized. But yes, it is expected that it would work on Kubernetes, the latest versions, since it is working on K3s and microK8s. Our end-to-end tests are not validating that currently.
Yeah,
that's a good point.
Cool. Anything else here, Kate, in the release note to talk about, or should we jump to the next item on the agenda?
I think we can jump or leap.
Yep. So next was the bug bash we had last week. So what's the latest on that, Kate?
Yeah, so I think, that was very new for us to kind of put out a community bug bash. I will say, I'm not sure how many people actually participated, but several people looked at the document. I feel like I was able to, here, let me paste that bug bash document.
Yeah, I was going to open it, but if you have it, awesome.
Here, I'll put it in the chat. So the intent here was, a lot of people are curious how to get started with Akri, and a bug bash is a really cool way to do that because you have to provide explicit steps on environment setup, on scenarios. And so you're not only getting started with Akri, but you're also helping, which is kind of cool because if worst case scenario came out, at least finding bugs and helping out. So this is something we might try and do again in the future. I think the first time was maybe us just like getting out the kinks and putting this out there, but the scenarios still hold. So you can still go ahead and do this bug bash. If we look through the scenarios, they basically were testing those 3 features that came out in our release. So testing that querying with CRI/CTL for pods worked. So we have basically logging in the agent that will indicate whether or not it worked or not. Our second scenario is ensuring that you can, in fact, apply multiple configurations with the same discovery handler. And then our third scenario was testing job support, and it walks through simple scenarios using, we have a discovery handler that discovers fake debug echo devices. And so it uses that just to validate that a job was deployed to each of them. And if we scroll to the bottom, you can see we did get some issues / enhancements out of these, and then all of the distros that we were able to test this on. And one thing I just really like to shout out in general, because it's awesome, is Kataconda has an incredible Kubernetes playground. Like if you scroll all the way up to the top, Roa, if you're ever interested in just getting started with Akri, it's pretty cool. It immediately will spin up a cluster for you, no cost, don't know how. I sign in with my GitHub, but it's free. And you basically can get started with a cluster immediately. You can install Akri. Helm's already on their clusters. So for the bug bash, we recommend using that if you would like to get started fast. Yeah, I'm curious if anyone has any feedback on a bug bash of sorts or have seen other communities do this. We thought it'd be cool, but I don't know if it's maybe a little far reaching.
Yeah, this is great. Actually, I've seen other communities who did that, and usually, actually, in most cases, it end up spanning multiple days. So I thought the scenarios picked here were really concise and easy to walk through. So I think that was a great start.
Cool. Well, let's try and do this for future releases. In the worst case, it's documenting more use cases for Akri and more test cases.
Perfect. Thanks a lot, Kate. So for that, I think we're at the point where we can have an open discussion. Any new topics that others want to bring up here? New contributors here? Any questions?
Yeah, I mean, one shout out to Jake, who's on the call. Jake helped out with our latest release, so he's in the release notes. So that's cool to see you here. But yeah, I know, Jonathan, you had some, oh yeah, sorry, go ahead, Jake.
Yeah, hi. I don't get reviewers on much of my Rush code, so I figure this is a good place to, contribute and see if I can get better that way. So thanks for letting me contribute and looking at that.
Oh, sure.
Yeah.
Welcome on board, and thanks for all the contributions. Keep them coming.
Yeah, totally. Yeah, I think Jake, you tackled, we're getting a little messy with our Clippy requirements, and Jake kind of cleaned it all up. So now we're at a good state with that. Yeah, and Jonathan, I know you've been looking at some scenarios incorporating a bunch of really cool technology on the IoT and edge. And I know you spent some time in the WASM space too. So I'd love to just hear if you have any thoughts or questions or discussion points, not to throw you like completely into the spotlight like I just did.
It's all good. I mean, that's why I popped into the regular call. I tried to add my topic in the discussion here, but for some reason I can't access HackMD right now. I think it's a user error, so apologize for not putting that in advance. But hi everyone, my name is Jonathan. I'm the founder and CEO of an IoT platform called Goliath. And one area that I'm exploring kind of in my spare time for the company is around device testing. And in the world of IoT, right, when you deal with devices more like this, having a sane test automation CI/CD infrastructure is actually not common. Every company I've ever worked at built their own bespoke solution, but every company needs it. And actually with the recent trend towards remote work, it's become even more important because we may not have 100 of these devices around to share. And so first and foremost, our team has an issue of device sharing across the world. We have customers who would like access to devices, and that's both for interactive. So, hey, I want this device. I want to write some code in it. I want to test it, as well as more traditional CI test automation stuff. And so I'm happy to do a kind of whirlwind tour of the world of device automation, device testing. But I prepared a very short diagram for Kate when we were chatting on Slack a few weeks ago. Let me see if I can, am I able to screen share? Is there permissions that I need to?
Yeah, I think Roa, can you pass it off to Jonathan, the host?
Yep.
Let me see. I think there's a setting for multiple screen shares, but
yeah, I was trying to get to that, but then I'll make you host and figure it out later.
Okay. Oh, well, let me enable multiple screen sharing in the meantime, and then so for those who are not familiar with this world, like it's usually a test engineer who writes a bunch of Python or Shell or Perl, and the engineers who write the firmware give them some code, say, hey, you figure out how to test it. It's like the classic waterfall testing that we've seen in other software disciplines. And so the world of CI/CD is relatively new. Now, this is let's say a reference design of something that we would love to have or love to exist. And there's some examples of projects that do something similar, but just to kind of walk through, I realize this is a very, very small font. But the idea is that at different test sites, that might be offices around the world, that might be, customer locations. There's a concept of a station. These are sort of generalized terms. And you'll see how this all ties to Akri in a hot minute. But, the classic, simplest possible way is you have a device. So like a device like this, I'm calling it a machine, has some test equipment. Maybe that's a debugger. Maybe that's other types of equipment, for example, monitoring power or consumption, and then some sort of computer nearby that orchestrates that test runner, or that maybe has a test runner or some other SSH access, et cetera. And then as you scale it up, especially in the world of IoT, you actually might have multiple devices as part of a station. So maybe, for example, machine B and machine C are connected over Bluetooth. And you need to be able to manage that network and control that network and maybe simulate network conditions. But no, as you scale this beyond more than 4 devices, it becomes increasingly complicated, as you probably can imagine. And usually there's a central coordinator, probably a cloud server, and then there's users accessing it via an API. Because I was feeling creative the other day, I decided to make a different diagram to represent it more realistically, right? Where users might be an engineer at a company, where an API or CI might be a test script that's run that gets deployed via a different coordinator. And so from like an architectural perspective, you can kind of squint and see, well, this sort of station or the local site manager might be a higher end computer, like an Intel NUC or a IT 1U rack, or it could be something a little bit smaller. And then a bunch of these machines are connected via the station through some sort of interface. Now, in this world with these kind of devices, these have 128 kilobytes of RAM. So, they're not running Linux. They're not running WASM for the most part. And they're just a deploy target. And invariably, almost all these devices are using USB. And so there's challenges around having lots and lots of USB devices and connecting, managing lots of USB devices. The other thing that makes this technically challenging is most of them have a USB converter on them. And why is that important? Because they all have the exact same UDEV rules. They're literally the exact same chip. I wish I could zoom in, but there's a little tiny chip on here that talks to the main chip. And that little chip has a VID, a vendor ID for USB that is the exact same as every single one that's made by this manufacturer. Because primarily this is not connected over USB, but that's how you interface with it. And so managing 1,000 USB devices, for example, or let's say 100 USB devices with all the same IDs becomes a problem for the software that's managing it. So that preamble is because there's some projects that exist that try to solve this today. One that's used by the Linux kernel is called Lava, Linaro Automated Validation Architecture. It's just a whole bunch of Python that's been developed over a couple of years by Linaro, which is a project associated with ARM in a company. And in that world, you write a bunch of Lava Python code, and you write your own handcrafted UDEV rules, and they actually have an abstraction layer, like a DSL for managing that. That's one solution. Some people use that. There's another solution, similarly, Python, lots of DSL and like munging of USB configuration via this DSL, and then a little bit of UDEV underneath the covers. And then that's kind of really the two largest open source options. And like I said earlier, primarily this is done with custom scripts, Python and Perl, and just craziness. I have some other links here that I won't get into it right now. So when I was thinking about how to solve this problem, I wanted to take a step back and look at the landscape. Is there something in the cloud native world that could be useful to maybe augment this or replace this? And a lot of these projects actually starting to move to containerization to make it a little bit easier to deploy, but fundamentally it's just a bunch of Python scripts with some DSL. And one of them is Akri. And fundamentally, it's sort of like maps this model, right? Like if you think of this, let me go back to my original diagram. This site manager as an Intel NUC, so like a Cortex, an i3 processor that can run a bunch of containers, let's say a container per machine. You have a dedicated, let's say, container attached to each machine that's running your let's say your shell script to SSH into the tiny microcontroller over USB, or running some toolchain software or CI scripts. So that like actually solves a lot of the class of problems that either DIYing yourself or trying to use one of the open source projects doesn't address. Now, it doesn't bring you the rest of the stuff that it understands, like what is a USB device, what is a microcontroller, what is an NXP microcontroller versus an Espressif microcontroller, but it does provide some of the fundamentals around managing, software packages that gets associated with a device that's over USB. So anyway, that was what inspired me to reach out on the Slack channel and chat with Kate a little bit. And I haven't made progress since a month ago or so, but I wanted to bring that up and see if there's any thoughts or ideas. The idea of like WebAssembly and trying to be more efficient with how let's say tests are actually written is actually kind of interesting. Like, has anybody thought about building a test runner written in WebAssembly? That'd be kind of cool for our domain. But fundamentally, just having the ability to access these devices remotely through a centralized coordinator, that actually is kind of interesting in and of itself. The USB challenge, I think, is the biggest one that is worth seeing if there's better solutions or other things to think through. But I'll pause there. I rambled for 10 minutes or so. So I'd love to get any feedback or thoughts.
That was great, Ramble. I mean, that's a very interesting use case. At least, like, I didn't think about that before. And I'm a little bit curious if you can, I think, maybe pass the links to. I got the Lava one, the other one.
Oh, sure.
That would be awesome to read a little bit actually about what control operations they actually do through automation. Because I'm kind of curious.
Yeah, definitely. And from their perspective, they assume that a USB device, especially these kind of devices, are black boxes. And so there might be some protocols that communicate via, so the ability to program those devices, so update firmware on them, or how you get debug information off the device. But fundamentally, they're a black box. So a lot of what they're focusing on is setup. So how do you, provision a device to make it accessible? What's the actual task? Is it running, let's say, a series of tests, or is it providing remote access via third party, like a proxy, like an SSH proxy? And so they really don't deal much with the protocol underneath. And the way that ends up happening is, this device, I'm gonna have some props, which I'm gonna check out for my blur because that might help a little bit here, and you'll see my little messy house. So this device is from one vendor, and this device is from another vendor. Right, this is a Wi-Fi device. This is not a Wi-Fi device. And this speaks one protocol for software updates, and this speaks a different protocol for software updates. This device, let's imagine this device has a debug port. This one doesn't have a debug port. And so when you construct the, let's say, the configuration for a particular device, you have to write all that information in their DSL, or somehow figure out how to do that through another scripting way. So like, you write a bash script, and that for this one device, because you're the only one who cares about this one device, then when it gets executed or a part of the test pool, then it knows to call out to something. In fact, actually, it's mostly reusable. Like there's a subset of stuff of these, let's say, bespoke programming and debugging protocols that in the world where we live in like for our IT platform and how we interact with our customer devices, that's a really well understood thing. But these test runners and remote access are not caring about those. They leave it up to the implementer to figure out. Does that cover?
Yeah. I think what you're saying is it's at this point it's less about the protocol and more about the vendor specific, which is again a little bit shareable as well because they are common patterns that are used across the industry. So yeah, that was good clarification. Thank you for that. Kate, you were trying to say something?
Yeah, I was just curious. So Jonathan, you mentioned how using a UDEV rule is not a way to distinguish these devices. And so Akri, one discovery method it does is via UDEV rules, but you mentioned some of them are Wi-Fi based for certain operations. Would discovery be one of those? So for that one device you held up that could do Wi-Fi for upgrades, or I don't remember which one it was, but does it also have a discovery endpoint? So for example, could you, for each type of device, have a discovery handler? So you discover this set of devices that support this functionality, and then this set of devices that support this functionality, and then do it kind of that way?
Yes and no, as all good answers are. The first and foremost assumption is that none of these devices have any software on them. So they are bare metal. And so when you're doing let's say a full test for a release, you're going to wipe the device completely. So there's no Wi-Fi stack on it, or it's not running. And so there's usually a bootstrapping process of getting some initial software on there, maybe configuring the initial software for that. But once it is set up, then there is different discovery protocols. And that starts to get into the IoT specific parts, like when you're actually talking about this is an IoT device, not just a bare metal device. Then for running IoT specific tests, you can make some assumptions. So for example, there are Wi-Fi discovery protocols, or actually more like HTTP discovery protocols that are pretty common, similar for Bluetooth. And so you can imagine having a different part of the problem space, like it's a bare metal device. I want to be able to access 100 of these bare metal devices and share those resources, like assume that is a USB device. Versus I'm running IoT specific protocol testing, and they have to have this firmware on them. And once they have that firmware, then I'm going to upgrade them or modify them, or I'm actually just going to be testing the protocol itself, not the actual firmware on the device. So yeah, there are definitely multiple ways devices are discovered, especially if they're running protocols. So that's probably more IoT protocol testing and discovery, which is also interesting. But I would say probably a second order problem.
So your first order is provisioning as well.
Yeah. So just assume that I have a NUC on my desk and I have a USB hub with 10 devices, and they're all USB devices. Maybe they're heterogeneous, maybe they're homogeneous. And so like identifying those devices, creating them as resources that are available for access, figuring out if they're online or not, are they still available, are they being currently used, those sort of resource sharing problems, which is really why I started poking around the Kubernetes world and anything related to CNCF, because it's kind of like a node, right? But it's not, right? And the way Akri thinks about devices is closer to that. Yeah.
Totally. And so do you think that you could, even though they're using the converters and therefore have the same, at least some of the same UDEV rules, is it entirely the same? Or do you think you could still do some differentiation of the device via UDEV?
So I'll walk you through the process. This is really funny. Well, what would you do in this situation, right? Your documentation says, take all your devices, make sure they're unplugged, plug one in, then do LSUSB, and then call that device one. Don't unplug it because it's going to change, and then plug in the second and third and fourth. So that's typically how you manage these devices, because like there's no real good option in Linux. And so because these are permanent or semi-permanent deployments, you're not unplugging and replugging devices. So you can at least assume that a device that's on a particular bus is the same device that was previously on another bus. And that's about as good as the world takes, because they're all using similar identifiers. Now, there's two exceptions to that rule. There are devices with unique device identifiers just built into the chip and are also reprogrammable. And so from a USB perspective, that makes it so easy. If you find in their documentation, they usually talk about the ones that have a unique USB ID because it's easier. Or second, either they have or they're using another piece of hardware. Actually, if I can screen share real quick, I had some more. When I was referring earlier to right, the scenario of equipment. Equipment is a general term I'm trying to describe here of something that's associated with that device. Maybe it's actually helping for its programming and debugging. Like not all devices have the capability to be software updated independently. They need a third-party device to actually take the firmware, instantiate the program, and reprogram the device. The most common one is something like this. Seger is the industry standard. You often are in this scenario when you're manufacturing, but it's also for development. And so you might have a USB on one end, and then do they have any nice photos of this? No, but you might have a cable, and then you'll have a cable from this debugger and programmer into your device. And so in that scenario, you have this dedicated piece of hardware that talks to your IoT device. And so both of them might be connected over USB. And in fact, there's another, there's some university programs that have some similar type of deployments. I forgot that. I should have included that. IoT Rise testing. Fit IoT. So this is a collaboration across the different universities in I think France primarily, and they all have a deployment. And what they'll do is, if I can find, nope, one quick diagram. I'm not prepared. Sorry for that. So this is used for academics, master's, PhD students who want to work on their papers. And so they need to be able to run lots of tests across lots of devices, measure the power consumption. So they're using different types of test equipment. And this is what I was looking for. So this is an inspiration for a lot of my area of research. And again, I'll if I can post all these in Hack, I will. Otherwise, I'll just drop it into Slack. But this is a great example. Instead of having one centralized, let's say Linux controller, each device is paired with it. So this is the test device, this is the controller device, and this is the Linux device that's communicating. It's because they have these different channels. They're actually using TCP/IP, not USB, but regardless, the external device, like the programmer, has to be external, and therefore they need to connect that to USB. And then they have a second device, the actual device under test, that's also connected. And then they capture all that data and stream it to as part of the infrastructure, because that individual device is required for programming and debugging. Why did I bring this up right now? Because that device, the debugger might have a unique ID. And while you don't necessarily know the ID of the device under test, you might know of its permanently affixed or semi-permanent debugger, and that could be associated with that device. And so you use that as a form of identifier. And the last nuance here is when a device is actually running. So while this device, I have 10 on my desk right now, they'll have the same vendor ID. When it's actually running, built into the chip at manufacturing time is a unique ID, but that's only accessible once the device is running firmware. So until you have the ability to load some firmware, query its vendor manufacturer provisioned ID, then you could, in theory, use that. But that's a couple steps removed from how these assumptions these infrastructure make.
So it sounds like the crux is figuring out how to identify these devices uniquely and ideally a USB-oriented way. One of the options would be via this equipment or debuggers, but beyond that, we would need more brainstorming. But if that were able to be done, then you could use Akri to discover, create these Kubernetes resources. Then those machines would have this basically inventory of all of the associated devices, and then you could perform your test scenarios, et cetera, on those devices. Yeah,
I think going down the path, right? Let's say we just want to focus on resource sharing. So my 10 colleagues around the world want to add all their devices to a super cluster of test devices, and any one engineer could have access to that device for programming, testing, validation. The container that's associated with that device could have all the tools, software tools they would need in order to debug that device, program a device. Maybe you'd have some software that, sample firmware. And so being able to spin up a container that's attached to that device would be super awesome. So they go to a little web app that says, I would like this device that's in Poland. Thank you. Now here's your external terminal that has SSH to the container that's attached to that device, and you can go to town. It's pre-configured with all the tools you need, so you can quickly get access and spin up, let's say, and deal with a customer complaint. Oh, this firmware is no longer working. Cool. That is, I think, in the realm of Akri and in the realm of what a lot of the other projects do, without the other fundamental, like adopting a DSL and figuring out how to actually manage the server, the actual physical servers and things like that. So yeah, that feels like a good starting path.
Yeah, that's a beautiful picture. I can totally see that playing out. I unfortunately need to hop off, but I would keep the conversation going. I'm going to definitely watch the recording, but yeah, I have to jump on the call for the webinar to prep. But this has been great, Jonathan. I love your diagrams and the discussion. So
thanks for inviting me.
Yeah. All right. Bye, everyone.
Thanks, Kate, and good luck. Jonathan, actually, I have a question. You talked about the bootstrapping scenarios. You mentioned that when you plug those in, you need to bootstrap them. Mm-hmm. So I'm just kind of trying to think if that's something Akri can help out with as well, or are those common protocols like the bootstrapping, or is it again device specific, vendor specific? For example, just when you're bootstrapping bare metal machines, maybe you have the Redfish APIs where you can, through iDRAC, do the provisioning and bootstrapping. I don't know, for the IoT word, is there a standard or a common thing that's used?
That's a good question. That's actually a really good question. The answer is no first, and then we can back into it. I actually think because the standards problem of any standards area, there are multiple ways to bootstrap. And really what we're talking about is programming. And so flashing firmware onto a device is going to be, there's N ways where N is more than 3. And some of them are proprietary. Some of them are common-ish, but not the same across vendors, as you can imagine with the proliferation of devices. I actually think the first order problem is there a concept of a bootstrapping process? So, and this is what a lot of these projects end up doing is okay, we don't know anything about this device that you're about to build a configuration for, but here's the place where you actually bootstrap. I think they call it booting or programming the initial image. Leave that up to the vendor to figure out, or the implementer to figure out how to actually do the prep work. And And then, all right, great. So if we have a well-defined way to set up a particular device, have you know, a place to call out for the device setup process, then the n equals more than 3, you can go implement the most common ones. And yeah, it's making that sort of bootstrapping as a concept as a first-class citizen. I don't know if it's already there in Akri. My level of understanding is pretty novice. But that would make a whole lot of sense.
Yeah, okay, yeah. It's not in Akri today, but I was curious if that is a scenario also we need to think about.
Yeah.
Yeah,
if you think about more classic test running applications, I think they share a lot of commonality, right? There's like a preliminary step. Maybe you have to prepare something. Maybe you have to, you know, build a file system. Maybe you have to set up a network. And until that's done, then the test can actually happen. And once, you know, you run a test, then there's some sort of testing process and recording the test, and like those differences vary across software ecosystems. And then when the test is done, you may need to do something afterwards, right? Maybe wipe the device. So I think those 3 primitives are, you know, re-implemented every time I've seen it, the projects, and that would be interesting to figure out if that's something that fits in the general case for Akri, and then we could leverage that as part of our, you know, bootstrapping, running, and decommissioning process.
Okay, yeah, sounds good. Yeah, that's a very interesting use case. I'm kind of curious. Do you know, like, you shared a couple of things like Lava and the other one, LabGrid, I believe.
Yep.
Do you know of other, like, maybe use cases, or maybe that's going to be on the documentation, I guess, of, like, you know, common things that the most common. I think you kind of nailed it though, right? You said just being able to discover those USB devices. Yeah. Interesting.
Yeah, and it's very similar. Like, this is why I keep on coming back to this potential path to managing a bare metal fleet of servers, right? You have to know that there's servers, and then you have to make them accessible, and then you need some access control, and then you need to determine if it's still running or still available, or currently being used by another client. And then when they have failure mode, so you have to be able to put them into some sort of quarantine. So like all that operational overhead is similar. And if you actually like spend some time going through Lava, a lot of those pieces are there. It's actually well-worn path. And Linux uses Lava for its kernel testing on, let's call it edge devices, not devices this small, because it's the same class of problems.
Interesting. Yeah. Thanks, Johnson. That's very informative. Does anybody else have any questions? Okay. Yeah. You know, I think that's. Oh, Edric, you're unmuted for a sec.
No, I'm just curious. So, are most of these devices, like, how wide range? Like you mentioned that there is different ways to flash it, but do most of them have kind of like a JTAG? Like, can you JTAG all of them and just kind of use that as a common ground? You know, obviously there's other ways, like a certain device might have a bunch of different ways, but if JTAG is sort of the lowest common denominator, would that be sort of a good, like a good first kind of common denominator first step to support, because it probably takes the biggest subset of the devices you have, even though I know some devices might have more proprietary or like more efficient ways to program them.
Yeah, I probably, when you were asking earlier about common programming models and protocols, JTAG is by far the #1 debugging protocol. And so JTAG, joint tasks, something. Anyway, it's the standardized protocol the industry has chosen primarily for manufacturing, but has been available more and more in development and testing. And it's called a testing protocol. A debugging protocol was actually also a programming protocol, which is exactly where you're going down the right path. Some of my background is in consumer electronics and production devices. And the thing about debugging protocols is actually they're disabled for finished products. And a lot of consumer devices don't even have them exposed functionally in the device, which is an oversight from my part, because actually what I was showing you is development boards, and many development boards have JTAG exposed. These two devices on my desk actually don't, primarily because they're small. So like small devices won't have the support or the ability to JTAG debug, where larger devices, sorry, I gotta see if I have all my props. Well, in any case, JTAG would be generally useful, but actually the few scenarios that we're focusing on right now, they don't have JTAG exposed because of the nature. It's a finished product, or it's a very small device to be included into like wearable type devices. But if you're asking about the most universally applicable in the terms of like the variety of devices, protocols, JTAG is by far the most common one, and probably would be more realistic for Akri as a project to explore to see if that makes sense.
Right.
Yeah, so that's a great, good point. The reason why, the other thing to keep in mind, which I'm rambling for quite a bit, USB is not the only interface that's used for debugging. And you saw that, I don't know if you catch in the diagram, but for the Fit IoT lab, they actually use everything for Ethernet. Because when you start to get to large scale deployments for large test houses, USB actually becomes a bottleneck. And so these debuggers will translate the USB based protocol over to Ethernet frames. And this is wild stuff. And then on the other end, actually convert Ethernet back to USB. And then that way they can have a humongous, let's say, 48 or larger Ethernet switch as opposed to a small USB hub. And so again, you end up having these bespoke, complicated USB IP protocol-y things. Sometimes they're proprietary, sometimes they're not. But when you're talking about like the smaller use case, I have 10 devices on my desk, and there's 10 employees across the world, and you want to manage 100 devices, it's primarily using USB over USB.
Awesome. It's interesting to know about the Ethernet usage as well. So yeah, thanks for sharing that, Jonathan. Any other questions or insights? So I think that's a great conversation starter. I think we can take the rest of the discussion on Slack and maybe the next community meeting as well, Jonathan. But yeah, thanks for bringing that up and sharing all your insights. I can definitely see Akri being part of that decision. So
yeah, that's awesome.
Awesome. Okay. So what else do we have on the agenda? Do we have triage today, Brian? I think so.
Yeah, there are a lot of issues.
Is there anything going on in Akri Word? Do you want to share screen? I can make you host too.
Sure, that'd be helpful.
Okay, you've got the superpowers.
Sweet. Okay. So we can start with gotta remove agent polling method for slot reconciliation. This is we touched on it briefly, talking about cry control being required because deallocate's not implemented. And so we've got some ideas around how to improve the cry control access that we're using. Currently we're polling. So I don't know, should we move this over to a backlog? I mean, it seems like it's a backlog item to me. We've done a lot of research for it.
Yeah, I totally agree. I think with some progress now on the deallocate, maybe we can wait a little bit more, but yeah.
Switch using container D as default away from what Kubernetes was using for standard before. Was that Docker shim? Or to me, this seems like something we should do because that's the direction Kubernetes is going. So it seems pretty clear that this should go into the backlog. Probably should even be a relatively high priority for us.
Yeah, totally agree. I think this is the one that's probably blocking the adding Kubernetes 122 there on the list. So
yeah, I think to get around that, we would have to kind of hack our test system a little bit, which we could do. It's just ideally we should adjust to the defaults of our various platforms.
Yeah, and just Jake and Johnson, maybe there's those good first issues that might be a good start if you want to contribute to Akri. So just wanted to mention that tag there. case somebody's interested, you can filter on that. Sorry for interruption, Brian. Go ahead, please.
Oh, no, interrupt away. And the next one is updating our dependencies on some Rust libraries here. Always better to stay on top of these things. I know when we started out, we were way behind, and it was a painful experience to move forward. So I also think that this factors into a later bug. It's mentioned below as maybe a solution to a bug somebody is seeing that we can't repro. So this seems like a good thing to do. It's probably a great first issue. Is we've come pretty close to I thought to the top of CubeRS. So keeping up to date shouldn't be too hard, I wouldn't think. Slide that over unless there's objections. Let's see, modify agent to reduce the frequency of pods. So early on, when the device plugin makes a request to our agent for a particular slot, this is kind of how we do device sharing. We were aware of a very specific condition where typically our device or our set of CRDs knows more than a device plugin knows about a shared device. In terms of somebody has asked for a capacity of 5 for, let's say, a camera, our CRD knows if 4 other devices have taken are accessing that camera. It knows it better than any individual device plugin does, any individual kubelet does, with one exception. And we knew about that. And so essentially that exception is if a specific device plugin or kubelet has previously had access to a device, it knows if the pod that was making that access request has gone down and is come back up and it's re-requesting that slot. So it knows, because deallocate doesn't exist, it knows that that slot has opened up and we don't. So historically, we made a note of that by saying, oh, well, previously this slot, this access point has been owned by this same node that's requesting it now. So we're just going to say, hey, no, you can't have it right now. We're going to clear our records of that slot, and then whoever requests it next gets it. It sort of democratizes the slot. That slot doesn't become monopolized by this particular machine. That crops up here in jobs a lot more than it has in pods, and it's really unnecessary. We can just sort of accept that a particular slot is monopolized by a device. There's no real problem there. So this is kind of about getting rid of that. And I think it's a good thing to get rid of, because this unexpected admission errors is going to cause people to think there's a problem when there's not. And really, there's no point to the error. I think this was just me initially thinking, oh, it'd be really neat if, we just opened up this slot and anyone could ask for it instead of the same machine getting it every time. So I don't know, if there are no objections, I move this over to the backlog. Cool.
Yeah, sounds good, Brian.
Let's see. Yeah, and this one, so we should maybe adjust our Helm charts to use Akri as a namespace for all of our resources. I think that sounds the way it should be to me. I'm not sure our reasoning for not doing it initially. If there are Helm recommendations against doing something like this, I'm not sure. It sounds natural to me to do. I would move this over the backlog. I don't know, Roa, do you have?
No, I think it's just the scope of it, I guess. I think it's the Helm recommendation is not to force the namespace to be something specific, but to update it through the release namespace through Helm. So yeah, I think as long as we adhere to that would be good.
Interesting. So my impression is that the default would be into Akri. So they're not against, that sort of sounds like it might be a little bit against what you were describing, but.
Yeah, the way I would do it is I wouldn't modify the chart templates themselves to be hard coded to Akri. I would let that to be defined through the release.namespace, and that we can have that like as a default through our documentation, and maybe others to be always Akri.
So you wouldn't have a values default to Akri. You would just let it be set. Okay. I'm game for that too. Either way, I think that, well, I don't know. I mean, to me, this bug is saying it should have a default value of Akri. Is that something that, go ahead.
Yeah, I think it's maybe an implementation detail, so we can keep it. If you want, you can maybe share a link to the task. I can pull it also as well, and maybe I can add a little bit more of what we got from our discussion with the Helm chart team, and maybe that.
Well, I mean, I think my guess is. Oh, I'm sorry. Go ahead.
No, go ahead, please.
My guess is that there is namespace work plumbed through. It's just there is no default. So maybe I'm wrong. When I read this bug, it sounds like it's asking for the default to be Akri.
Yeah. So I think what one way you can do that is when you're doing Helm install, you do -- namespace Akri -- create namespace if it doesn't exist. I think it was create - namespace, which would do exactly that. And that will, I think we need to update. That might end up being a documentation fix, in my opinion. But yeah, I think that we can keep the bug. We can move it to backlog. I can add a little bit more details on the guidelines.
Cool. Thank you for clarifications. So we've got a few bugs to end up with here. This pods generated for jobs contains consecutive dashes. Seems to be, I read through this one, it seems to be specific to, it seems to be a very specific version of Kubernetes that this happens for. I think there's some conjecture there that there's a problem in Kubernetes that has been fixed with more recent versions. I spent a second trying to poke around in the jobs controller to see if I could find a code update that could account for it, and I didn't in my 5 minutes of searching. But I think this could easily be just a recommendation or even a release note that says this happens in some versions of Kubernetes, and that might be all that we do here. I'm not sure that it impacts functionality at all. It's just like a weird observation. My suspicion is that this one might go into investigating more so than backlog, but if anyone else has objections, I will just move this to investigating. Maybe I'll add myself if I can to it. Okay. And then we've got agent pods are failing. There seems like a really specific bug that we have been unable to repro and have request out to the person that filed it for more details. And it might be tied to a version of the Cube library we're using, maybe not.
So this is the one that's wrapped around Azure Kubernetes Service. If you want, Brian, you can assign it to me and put it under investigating. Like I couldn't referee my setup, at least. So I plan to follow up based on that, so we can do that.
Investigating?
Yep.
Good. Cool. And we've got this one. Let's see if I could just get the shared screen. Let's see, Safari. This one I don't know a ton about. Looks like we've got a question out and haven't been able to repro it. Maybe it's a result of some incompatibilities with our kind of demo code and platform someone's trying it on. It's not super clear as to what it is.
Yeah. Do you want to keep it in triage or?
I was going to say, I think we could let this one sit on the vine until we hear back. And if it times out, then so be it. And if it doesn't time out and we get better details around where this is reproing and we can figure it out, then we can address it.
Yeah, sounds good. And looks like maybe Kate took a step on this, so maybe she'll have something to add. So up to the next Akri community meeting, I guess.
Okay, cool. Then that's all the issues we've got.
Thanks so much, Brian, for walking us through this. We're a little bit over time, so I think we can end up here. Thanks for joining, everyone, and see you next one.
Thanks, Rob.
Bye-bye.